coat of cement paste. The particle at the bottom left is a cement particle surrounded by calcium silicate hydrate, which is also surrounded by tringite, growing in the soil. Now, if you will, Carlito, go back to the one for the aluminum. Down here, this is good. You see that tringite raised here? And that's about 1 day, well, about 2 days. Then it starts to follow. That's what we want. Yes, because the soil doesn't swell. The monosulfur goes up, but its curve is flat. This is the calcium hydroxide, and it continues to remain flat, and it equals 20% of the paste. And here is the calcium sulfate hydrate, and it's 65% of the paste. So this shows you basically what is happening as far as this soil while it's cured. Okay, Carly. Hydration of cement particles. I won't explain that, but you can go to the next slide. And this is the way it looks. This is a cement particle. This is the clay platelet. This is the cement bonding or lime bonding with this clay particle, which is the mineral known as pozzolan or aluminum or silica. This is unhydrated cement grain. And this is the water that's put into the cement as a catalyst to start the reaction. And here we have the cement hydration products, the calcium aluminate hydrate. Is that understandable?
¿Está claro? Puedo explicar un poco más.
Okay, here's the plasmonic reaction where lime is used. Back one. I'm sorry. Go ahead.
Básicamente lo que está ahí en café son más partículas de arcilla y las líneas que están rayadas diagonal es la cementación que produce la estabilización. Esa es una reacción que se da entre los materiales puzolámicos de las arcillas y el estabilizante. O sea, los materiales puzolámicos son los aluminatos y los silicatos que están en las arcillas. Básicamente esa es la manera como actúa la estabilización, produciendo un efecto de cementación entre las partículas del suelo.
Okay. This is essentially the same, except basically the cementitious material from the pozzolanic reaction.
El material cementicio de la porcelana reacciona con hidrosilicato de calcio.
Is given to us as calcium sulfate hydrate, calcium silicate hydrate, and a calcium aluminate hydrate in the presence of lime.
Sí.
That's the way the molecule looks when it's...
Sí, la reacción se da básicamente en presencia de cal entre los materiales pusilámicos del suelo.
Okay. Comparisons.
Comparaciones.
We can use several different types of dry bulk additives, which gives us more an opportunity to pick the most economic one. And some of the things that we have to worry about is the magnesium oxide in some of the lime, which causes a problem. And obviously the sulfates. Here we have a comparison of the Portland cement, Class C fly ash, Class F ash, and ground granulated blast furnace slag. Okay? And in a lot of countries, all of these are available. And these are the formulas that we like to have for Portland cement. We need this much calcium oxide, this much iron, this much aluminum, this much of silicon dioxide, less than this amount, and no greater than that as far as the sulfate, and this 1.1%. This is Class C fly ash, and it gets its name from its designation of testing by ASTM C618.
La norma ASTM 6816.
Okay, Class C fly ash comes from the result of burning subbituminous coal in a coal-fired generation plant for electricity.
Básicamente, esas son cenizas volantes que vienen de una planta de generación de energía a base de carbón. Y es un desecho industrial realmente.
You can see there's quite a difference between this one and this one. This is also a fly ash that comes from coal-fired generation of electricity, but it's lignite. It's dirty coal. And then we have the granulated blast furnace slag, and that comes from the steel manufacturing. Okay? This is cement, fly ash, and this is the way the slag cement looks like. Okay? The morphology of fly ash is spherical and hollow inside, but it has enough clay, which are plasmin, and not quite enough lime to do what we need to do in stabilizing clay. So generally we mix it in combination with a certain amount of lime. And that again saves money if it's available.
I'll explain a little bit.
Okay?
Básicamente cuando se produce cemento, realmente lo costoso dentro de la producción del cemento es el clinker. Para reducir el costo del cemento se mezcla con materiales puzolánicos. Material puzolánico como las cenizas volantes que mostró ahí, la tipo C, la tipo F y las escorias. Las cenizas volantes se pueden usar para estabilizar suelos también, pero tienen un problema que no tienen suficiente cal. Entonces, si nosotros mezclamos cal con cenizas volantes, podemos tener un material mucho más económico y ahorrarle dinero a los clientes. Go ahead, Mr.
Okay. Now, all of these additives that I've shown you has a derivative, if you will, of calcium. And all of them, as a result, can be used with base seals, which is the polymeric catalyst. Yeah, and it's the one that gives us the flexibility
El que nos da una
and
flexibilidad
non-cracking.
y que no se quiebre.
Okay, here we have primarily
Aquí podemos ver principalmente
the behavior on sill
el
sides
comportamiento de
of
las
all of those
de los
four
siete
that we
tamaños,
mentioned before.
tamaños y mezclas que hablamos anteriormente.
This is percent pass in various
Es un
different sides.
porcentaje
It's basically the gradation of the material.
en el material.
Okay, Carlito. Important steps to follow when
Pasos
soil
más
stabilizes.
importantes que se tienen que tener en cuenta cuando se hacen las
Testing of the
pruebas de suelo
soil
es hacer una prueba de
is
suelo.
very important
Es muy importante
before you start.
antes de empezar a realizar el trabajo.
Because if we can't do it in the
Porque
lab,
nosotros podemos realizar en el laboratorio,
we can't do it in the field.
no lo podemos realizar ya cuando estemos en el terreno.
The quality control
La calidad y el control
is something that has
es
to be
algo que
done,
tiene que ser realizado.
and in many cases written up
En
as
muchos
built,
casos,
as built,
what?
as built.
Como construir, como construir.
So as our client knows exactly